Bismillahirrahmanirrahim. So here we have a problem. Uh, Let x and y be discrete random variables with joint PMF, which is given below. Px comma y is equal to 0.01 for values of x from 1 to 3 to 10 and values of y from 1 to 3 to 10, and this is 0 otherwise. What is the PMF of w is equal to min of x comma y? So we are to find the PMF and probability model of the derived random variable w, which is a function of random variables x and y. So before we begin the solution to the problem, let us explore this function minimum of x and y. So we have two random variables x and y. So if x is for example less than or equal to y, we can say that the minimum of the two values is x. So we could actually express this function here as if x is less than or equal to y, so min of x or y will be equal to x. And on the other hand, if y is less than or x, or we can say that x is greater than y, in that case then it will be y, min x of y will be y. So this is how this function is defined, and this is how this derived random variable is a function of the random variables of x and y. So to solve this problem, so begin solving this problem, let's consider this scenario that min of x comma y is greater than some value w. So we have these two scenarios here, so let's combine them with this one. So let's consider first if x is less than or equal to y. So in that case, consider that it will min x y will be equal to x, right? So if x is less than equal to y and min x comma y is greater than w, then x is, this is min x comma y is greater than w. So min x comma y in this case is x, right? So x is greater than w in this case. So x is greater than w and y is greater than x. So y is greater than x and x is greater than w. So y is also greater than w then, right? And in the second scenario, when x is greater than y, so here if x is greater than y and min x comma y is greater than some value w, so in that case also here now the minimum of x and y is y, right? So min x comma y is greater than w, so we can write that y is greater than w because y is the minimum of these two, right? So y is greater than w, and so x is greater than y then, and y is greater than w. So it means that x is also greater than w. So in both these cases, both these scenarios, you see that in either case we can write that. So in either case w min x comma y greater than w, it implies that x greater than w and y greater than w, right? So let us now consider the CDF of random variable w. So fw of w is equal to probability that random variable w is less than or equal to some value w, right? So we know that this is also equal to 1 minus probability that w is greater than w. All right, and this we have derived here. This W is basically W is equal to main xy. So main or minimum of x comma y is greater than W, right? But we have here derived this relationship, this one here, so we can use it here now. So FW of W is equal to the probability, this 1 minus P x greater than W comma y greater than W. So according to the definition of independent of random variables, if x and y are independent, then we can say that all right, or vice versa, right? So the joint PMF is equal to the product of individual, this joint CDF is equal to the product of the individual CDFs, right? So we can sorry, these are not the CDFs, actually the functions. So probability x is greater than W and multiplied by the probability that y is greater than W is equal to the combined probability, joint probability that x is greater than W and y is greater than W if the random variables x and y are independent. So we can write this here like this: 1 minus probability that x is greater than W, probability that y is greater than W, right? And we also know that probability that x greater than W is equal to 1 minus probability that x is less than or equal to W. And this is actually this is the CDF that f and this is CDF of X evaluated at W, right? And probability that y greater than W is given by 1 minus P probability that y is less than or equal to W, and this is now the CDF of y evaluated at W, 1 minus Fy at W. So we can substitute these relationships here in this equation. So Fw of W is given by 1 minus, so big bracket here, 1 minus this is equal to this relationship, right? So 1 minus Fx evaluated at W, right? And then here this relationship 1 minus Fy evaluated at W. So we are left with simple multiplication now. So 1 minus, so 1 multiplied by 1 and then this one, so 1 minus Fy of W, and then this Fx of W multiplied by first with 1 then with this Fy of W, so we will get minus Fx at W plus Fx at W Fy at W, right? So Fw of W is equal to, let's open the bracket, 1 minus 1 plus Fy W plus Fx at W minus Fx at W Fy at W. So Fw of W is, this cancels out, Fx evaluated at W plus Fy evaluated at W minus Fx W Fy W. So this is the relationship. Had we had the joint PMF of the random variables of x and y, or the individual, we could have derived the marginal functions, and then we could use this relationship to build uh, the CDF of random variable W. So now let's move towards solving the actual problem. So this is the general relationship for this case. W is equal to min x y, min x comma y. This is the general relationship in this case. So for the given problem, let's consider some random value W here. For example, let's consider that let x is equal to some value W, right? So for this case, x is equal to W will be a straight line, right? X is equal to W will be a line something like this. And for y is equal to W, that will be another straight line like this, horizontal line now, y is equal to W, right? So if we now consider the region that min xy, let's consider this region, min x comma y greater than W, and this is actually we have already found out here is x greater than W and y greater than W. So x greater than W is this region right here, and y greater than region is this region here. So intersection of this is this region. So it is this region, right, towards this section, which signifies this x greater than W and y greater than W. So if we are interested to find the probability, for example, that W is greater than small w, or this is min xy, actually min x comma W is equal to min x comma y is equal to this. So this, in other words, is equal to probability that x is greater than small w and y is greater than small w. This we found out here, right? So this probability can be calculated by summing all these probabilities here, right? So we need to find out the number of entries this row and number of entries in this column, to multiply them together to find the total number of entries, and then multiply by the probability of each entry, each point, to calculate the entire probability. So probability of each point is 0.01 here, right? 0.01 here. There are total number of 10 entries in each row, and there are total of 10 entries in each column, right? For example, these are 10 entries here, these are 10 entries here, so 10 multiplied by 10, there are total of 100 entries, and 100 multiplied by 0.01, which is the value of the probability at each point. So this comes out to be 1, the total probability of this region. But we're not interested in the total probability at this point, we are interested in the probability of this region only. So the length of this row here is 10, this is 10 in total, and minus this W, right? So this will give us the length of this row. Then again, this is 10 in 10, length of this column is 10, and then minus this W here, right? So this will give us the length of this column. So 10 minus W multiplied by 10 minus W, 10 minus W multiplied by the probability of each point 0.01. So that will be 10 minus W square multiplied by 0.01. So this is the probability of W greater than W. Let's consider a similar scenario again, but now let's consider probability that W is greater than or equal to W. So greater than or equal to W will include this line also, right? So in this case now 10 minus W and plus 1, right? So this will be 10 minus W plus 1 for the row and for the column also. So this will be squared here, right? multiplied by the probability 0.01. So again this will be equal to 11 minus W square into 0.01. So we have these two probabilities now, probability W greater than W and probability that W is greater than or equal to W. So it's easier for us now to find out the PMF, probability PW of W is equal to basically that random variable W takes on small value W, right? And this is equal to probability that W greater than or equal to W minus probability that W is only greater than W. We have both these probabilities now. So PW of W, we put in this value here, 11 minus W square multiplied by 0.01 minus, and the probability that W is greater than or equal to W is this one, 10 minus W squared into 0.01. So 0.01 can be taken as common, right? So we left with 11 minus W square minus 10 minus W square. So this is 0.01, simple arithmetic now. So this is 1 to 1 plus W square minus 22W, right, and minus 100 plus W square minus 20W. So 0.01, right? This is 121 plus W square minus 22W minus 100 minus W square plus 20W. So W squares, they cancel out, and PW of W is 0.01, and 121 minus 100 is simply 21, and minus 22W plus 20W is simply minus 2W. So this is the expression for the PMF of the random variable W. And random variable W also takes some values from 1 to 10, like random variables X and Y. So W is only a function of X and Y, minimum value of X and Y, right? So it takes on only those values which X and Y take. So if X takes from 1 to 10 and Y takes 1 to 10, so W also takes these values from 1 to 10. So the complete PMF for random variable W can be written something like this: 0.01 into 21 minus 2W. W is equal to 1, 2 till 10, and this is 0 otherwise. So this is the solution to this problem.